Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 30 of our complete DevOps course, and in this class we will start our journey with Kubernetes. So firstly, Kubernetes is easy. Yes, you heard it right. So many people worry about Kubernetes, and whenever we talk about DevOps, people focus most of their time on CI/CD solutions. So I've seen many people focusing a lot on building pipelines, talking about live CI/CD project. And even if you search on YouTube, you'll find bunch of CI/CD related stuff on YouTube, and everybody is focused on it. But the key player in the market is Kubernetes. Take 20 resumes, search for DevOps related jobs. If you don't find Kubernetes, you can definitely come back and in the comment section ask me, okay, I did not see Kubernetes in one of the videos, but you are saying Kubernetes is important. Trust me, that will never happen because in all of the job descriptions, you will see Kubernetes because Kubernetes is the future. Kubernetes is the future of DevOps. So if you want to do a marathon journey in DevOps, right? If you want to do a short sprint, or if you just want to get into DevOps and you just want to be around in DevOps, then yeah, you can survive yourself by just learning about simple DevOps topics. You can do projects on CI/CD, and you might also find some simple DevOps job roles which offers you some positions, but it's not DevOps. It is basically build and release engineering, or it is basically some release engineer roles which offers you jobs on just CI/CD and other DevOps stuffs. But if you want to, like I told you, do a marathon in DevOps, or if you want to do a long run in DevOps journey, Kubernetes is the future. Now, why I'm saying this? Because everybody knows that these days people have started moving towards microservices. Now, not these days, people have started moving towards microservices from last 6 to 7 years very actively. And you all know from last 6 classes, we have been talking about Docker and containers, right? So I have explained enough why containers are very important. If you haven't watched our previous videos from day 24 to day 30, day 29, if I'm not wrong, we just talked about containers, evolution of containers, introduction to containers, importance of containers, and we also did some live projects on containers, that is using Docker. So if you haven't watched that videos, I'll highly recommend you to watch those videos before you jump onto Kubernetes, because the only prerequisite for learning Kubernetes is Docker. Now, why do I say Docker, not containers? Because most of the people are very acquainted to the term called Docker. They relate themselves more when we say Docker, but in general, I'm talking about containers. So if you want to be a key player in this space, you need to understand the concept of containers very well. It's not like when I say understand containers, don't talk about simple Docker commands. Okay, I'm not talking about the Docker commands at all. Whenever I speak to you in my videos, what I always tell you is get strong with your basics. So I am only talking about the basics of the containers. That means you need to understand what container is bringing into the picture. How is it different from a virtual machine? What is your networking isolation? What is your namespace isolation, right? And why containers are very lightweight in nature. You all know that containers are lightweight, but why are they lightweight? How do you secure your containers? We talked about distroless, we talked about multi-stage Docker builds. So learn about all of these things before you start your journey with Kubernetes. Now I am assuming all of you have watched my previous videos from day 24 to day 29, or you already know the concept of containers and Dockers very well. Okay, so this is the assumption that I'm making, and I'm going forward with today's video. So I'm again saying you, if you haven't watched the previous videos, or if you do not have the concept or the understanding of containers, then don't go forward, but instead go back and watch the previous videos. Okay, now the first question that you should get before learning Kubernetes is, what is the difference between Docker and Kubernetes? Okay, because from day 24 to day 29, I explained you how to build projects on Docker. We deployed some real-time applications. We secured the containers using distroless images, multi-stage builds, and we saw about the life cycle of Docker and containers, and how Docker, which is a container platform. What was Docker? I also explained in the previous class. Docker is a container platform. That means Docker is making you the interaction with the containers, or Docker is making your container journey very easy because it provides you a complete container lifecycle, whether it is using the Docker engine or using the Docker CLI. It makes you it makes your container journey very easy. But now, what is Kubernetes then? So if you already have a container platform, and if the container platform is offering you a lot of things, what is Kubernetes? So for the textbook definition, Kubernetes is nothing but a container orchestration platform. Okay, so what is Kubernetes? Kubernetes is a container orchestration platform. So this is for just a textbook definition of understanding. That means just for your one word answer, you can say that Docker is a container platform, whereas Kubernetes is a container orchestration platform. That does not make you understand anything, right? If I just tell you here that, okay, learn about Kubernetes. Kubernetes is just a container orchestration platform. And if I close this topic here, you will not understand anything if you are just a beginner with Kubernetes. So let's try to understand the practical implication, or what I am like, by container orchestration platform, how is it different from Docker platform or a container platform? Let's try to see. Now, if you have worked with containers before, one thing that you will notice is containers are ephemeral in nature. I used this term previously also. If you haven't, I mean, if this term hasn't got registered with you, ephemeral is nothing but something that is short life, or short living in nature. That means containers can die and revive anytime. So what do I mean by this? Basically, if you have a host, let's assume that this is your host, on top of which you have installed Docker, on top of which you created, let's say, some 100 containers. Okay, now one of these containers is taking a lot of memory. Okay, all of a sudden it started taking a lot of memory. So this one impacts your 99th, or it impacts your 50th container. Why it impacts? Because this container is not getting enough resources, so it will die. Or if it is already not scheduled, what happens is this container will not get started, right? So basically the life of containers is very short if there is lack of memory resources, or if there is some issue with the container, like the image is not getting pulled. In any of the cases, the container will immediately die, because there is only one host here, and on top of that I installed 100 containers. One of the container, there is no relation between container number 1 and there is no relation between container number 100. But still what is happening here is the container 1, which is consuming a lot of memory, is killing the container 100. It is not directly killing, but because of the Linux, how Linux works. Okay, so if you want to understand this thing in deep, what happens is there is priority that is allocated for each process in Linux. So now what happens is that when one of the process is taking a lot of memory, depending upon your Linux and kernel rules, the process, like Linux have to define, right, or kernel has to decide which process to kill. Let's say there are 100 process, it cannot randomly kill process number 50, right? So there is a particular algorithm in kernel using which it deletes one of the processes. So here in this case, what I'm telling you is container 1 was taking a lot of resources, because of which container 100 is not at all getting created, or it is directly dying. Okay, so this is one use case. What is the problem here? Because you have only one host, and on top of it you have installed Docker, and you have created 100 containers. One of the container is dying because of the other thing. So what is one problem that we have learned here? Single host. Okay, so this is problem number 1. Now let's move to problem number 2. What is problem number 1? The nature of Docker, or the nature of this container platform, is scope to one single host. So because it is only one single host, the containers which are there, it is impacting each another. And if one of the container is impacting the other container, there is no way that this container can come up. Okay, so this is problem number 1. Now the problem number 2. Let's say somebody has killed one of your container. Killed container. Now what will happen if somebody kills the container? Immediately the application that is running inside the container will be not accessible, right? What is the reason for it being not accessible? Because the container got killed, and unless there is a user or a DevOps engineer who starts this container, somebody has to act upon the container that got killed. Okay, so this behavior is called as auto healing. Okay, so what is auto healing? Auto healing is a behavior where, without user's manual intervention, Okay, so without the user's manual intervention, your container should start by itself. But does it happen in the Docker? Let's say you are playing around with your Docker containers on your personal laptop. Does the container come up automatically? No, it does not come up. Now, there are hundreds of reasons why your container can go down. Okay, so there are hundreds of reasons why your container can go down. Now, the problem is that a DevOps engineer cannot continuously monitor some 10 thousands of containers. Okay, so in your personal laptop, you might have just one single container. But when you are working in production or when you are working with your organization, you will see some 10 thousands of containers. Now, you can always not do Docker PS, right? Always a DevOps engineer cannot perform the Docker PS command and see which containers are in running state. So there has to be a mechanism that is called as auto healing. So auto healing is a very important feature that Docker or any container platform by itself is missing. So what is problem number two? Auto healing. What was problem number one? Single host nature of your Docker container. Now let's move and see what is problem number three. So this problem number three is called as auto scaling. Now let's try to understand what is this problem number three. So again, let's take the same example. You have a EC2 instance or a physical host on top of which you install Docker. Okay. On top of which you have, let's assume you just created one container. Okay. Just for easy understanding, in usual terms, you will not just create one container, but let's say that you just created one container and this container, you know, it has some resources called as, okay, this host, let's say it is a 4 GB RAM and 4 CPU. Now this container can maximum consume up to 4 CPU and 4 GB RAM because it is the maximum capacity of your host. In general, your container will not get all the required resources from your host because the host itself has a lot of processes that is running, right? But for easy understanding, let's say maximum this container can go up to 4 CPU and 4 GB. Okay. Or, for some reason, what has happened is your user, whoever is the user, okay, so you have some 10,000 users. Your application has some 10,000 users. But what happened is during a festival season, let's say some Christmas or Dasara or any festival season, your users all of a sudden went from 10,000 to 1 lakh. So this happens all the times, right? So let's say a movie is released on Netflix, and this is a very popular movie, something like Marvel or Avengers or any popular actors movie. So usually Netflix might receive load from 10,000 users, but on this particular occasion Netflix will receive some 10,000, sorry, some 1 million or 1 lakh or whatever, the load gets increased. So to satisfy this increasing load, or to for the container or the application to act upon the increasing load, you need to have a specific feature which is called as auto scaling. Now what is auto scaling? As soon as the load gets increased, okay, there are two ways. One is manually you increase the application. There is only one container, right? So manually you increase the container count from 1 to, let's say, 10. Okay, because the load is increased by 10 times. I'm just giving an example. So manually you increase the load from 1 to 10, or the containers, similar containers, like similar to C1, what you will do is you will create 10 different C1 containers, or it has to happen automatically. Okay, as soon as this sees the load, the Docker container, it has to immediately understand that, oh, okay, so the load is getting increased, so I have to scale up myself. But Docker does not support both of the things, right? So let's say you have one container called C1. Okay, so manually what you will do is, let's say you want to increase from 10,000 to 20,000 user requests. What you have to do, you have to create another container called C1, and apart from this, you have to configure load balancing. Okay, if there is no load balancing, you cannot tell user that, okay, for first 10,000 users, access my application URL as 172.16.3.4, and for next 10,000 users, access my application on 172.16.3.5. That is not possible. Netflix will never tell you this, right? All that you do as an end user is just access netflix.com. Okay, so you just access netflix.com and your favorite movie. So now what is happening behind the hood is there is a load balancer which is actually sending you the load. whether you are doing it manually or automatically, whether you increase this containers count manually from 1 to 10 or automatically if your platform is increasing from 1 to 10, behind the hood there is a load balancer. Okay, so this load balancer basically says that, oh okay, now I understood that instead of one container there are two, or instead of two there are three, or there are 10, so let me equally split the load. Okay, so there has to be this mechanism of load balancer which supports your auto scaling. So this is feature number 3 which is missing in your Docker. Okay, so what are the three different things that I told you? The first one that I told you is the problem that we had with the containers is it is a single host one. That is, the Docker platform basically relies on one single host. Whether you install it on your laptop or EC2 instance, what you are doing is on one specific EC2 instance you are installing Docker, and top of which you are installing containers. Whether the containers are like, if you have 10 containers, 100 containers, you are just simply installing on that specific host and you are serving the traffic. Okay, now the problem number 2 that we have is auto healing. What is happening with auto healing is that your containers are not able to heal automatically. If the container is dying, then DevOps engineer should keep track of this 10,000 or 1 lakh or 1 million containers, and he has to start by himself. Or when customers report that your application has gone down, you have to start, which is a very bad user experience. Now the problem number 3 I just explained is about auto scaling. And the problem number 4, or the final problem that I want to bring here, is Docker is a very minimalistic or very simple platform. Okay, what is simple platform? By default, Docker does not support any of your enterprise level application support. Okay, Docker does not provide any enterprise level support. Now what do I mean by that? Let's say you don't know Docker at all. What are the minimal things that you require for running your application even on a virtual machine? Okay, so it's not like running your college project. If you want to run your college project, you can just run it on your laptop. But when we deal with enterprise applications or when we deal with enterprise solutions, you have a lot of things to deal with. So one of the example is your application should have a load balancer. Let's keep writing firewall. Okay, without load balancer your application is not enterprise ready. Without firewall your application is not enterprise ready. Or there are some such parameters. Let's keep writing them. Okay, and what is the other thing? Your application has to auto scale, or at least it has to support scaling. Your application has to auto heal, or at least it has to support healing. Okay, and then your application has to support some API gateways. If you keep writing, this number will go, it will keep increasing. Okay, so what are these things called? Some enterprise level standards. But Docker does not support this enterprise level standards by default. Okay, or instead of you going to Docker Swarm or any other high level Docker concepts, by default if you're just using Docker, these all things are not supported. So it's a very simple or minimalistic platform. So who is solving all of these problems? Let's write all the four problems here and let us see how Kubernetes is solving each of these problems. The first problem is a single host. Second problem is auto scaling. Third problem is auto healing. Fourth problem is enterprise level support. I'm sorry if there are any typos. So these are the four problems that we discussed. There are hundreds of problems, but these are the four problems that are very important. Now I cannot tell you all of the problems because we are just starting our journey with Kubernetes. Now who is solving these problems? As I told you, the one simple answer is Kubernetes. So now you can answer this question, right? If somebody is asking you in the interviews, who is solving you the problem of Docker, or what is the difference between Docker and Kubernetes? Okay, so if somebody asks you this question, you have the answer now. Okay, so all these 5 slides or all these 15 minutes, I just talked about this one simple question, the problem with Docker or the difference between Docker and Kubernetes. So now you should be able to explain these problems. Let me tell you the solutions immediately. Okay, so till now I just explained you the problems with Docker and I just told you that Kubernetes will solve the problem. But I know that you people will not trust me. You will say that, oh, okay, explain me. how it will solve. Because if anybody says you that, oh, okay, Kubernetes solves the problem, you should not trust. You should ask the question, okay, explain how Kubernetes solves this problem. So let's try to understand. By default, Kubernetes is a cluster. What is a cluster? Cluster is basically group of nodes. Okay, so previously when we installed Docker, we just installed on one personal laptop, or we just installed on one simple EC2 instance. So Kubernetes in general, in a production use case, it is installed in a master node architecture. Okay, so what is master node architecture? Just like Jenkins, we create clusters. So that means to say, whenever we install Kubernetes, we just create one master node and we create multiple nodes. Okay, so somebody will directly ask me, oh, does that mean Kubernetes cannot be installed on one single node? You can definitely do it, but that is only your developer environment. Okay, so to just practice Kubernetes, or to just start working around with Kubernetes, you can also install Kubernetes on one single node. But in general, in production, Kubernetes is installed in, whether it is high availability or a standalone mode, Kubernetes is generally installed as a cluster. So now what happens? Okay, I might be installing it as a cluster, but your question will be, what is the advantage that I get if I install as a cluster? The advantage would be, in the previous slide I told you, if you go back to this problem here, I told you that this container is actually getting affected by this one container that is taking a lot of memory. Right now, what will happen is, if you install Kubernetes, in Kubernetes there are two nodes, let's assume. So if this node, okay, so let's assume this is this specific node, and this is container 1 and container 99. Okay, so if container 1 is impacting this container 99, immediately Kubernetes will put this container 99 in a different node. Okay, so that what happened, this container 99 is not affected by this node. Or the meaning is that a faulty node, okay, so there is a faulty node, for example, or there is one faulty application in the node which is impacting the other applications. So Kubernetes, because it has multiple node architecture, immediately it can put nodes in a different pods in a different node, or applications in a different node. Okay, so because of which you have a cluster like architecture. Okay, so this is one problem that is already solved by using the cluster behavior of Kubernetes. So Kubernetes is by default cluster in nature. Now the second problem, what is that? Auto healing. So Kubernetes basically has something called as, uh, okay, I don't want to go into the details, but Kubernetes has something called as replication controller or replica sets. So replica set is a new name, replication controller is the old name. Okay, just like you can consider version 1 and version 2. So Kubernetes has something called as replica set. So all that you need to do is, you don't even have to deploy a new container. Okay, let's say you have C1. Okay, and your C1 or your application is receiving load, increased load. Previously it was receiving 10,000. On one festival it is receiving 1 lakh, for example. Okay, or 1/10 of a million. So what you can simply do is, Kubernetes is basically dependent on YAML files. So everything in Kubernetes is all about YAML files. So in replication controller.yaml file, replica set controller.yaml file, or even in the deployment YAML file. Now if you don't know what these terms are, don't worry. All that you need to understand is, as a DevOps engineer, you can go to one specific YAML file. YAML is basically a indentation format file, just like JSON files. Okay, so you can simply go to this YAML template file and say that increase my replicas from 1 to 10, because my traffic is increasing. I know that tomorrow is festival, so I want to increase traffic from 1 to 10. This is manual way. And Kubernetes also supports something called as HPA, which is horizontal pod autoscaler. Okay, so using which you can directly say that, okay, whenever there is a load, just keep increase. Okay, if one of my container is receiving a threshold of 80%, so whenever you see that the load is reaching threshold of 80%, just spin up one more container. Okay, so in such cases it will keep up spinning containers. If the load is even going from 1 million to 10 millions, even your horizontal pod scaler feature of your Kubernetes can handle. So this is how you are achieving auto scaling. Two problems solved. Now let's go with the problem number 3. What is the problem number 3 that I told you? Auto healing. So what is auto healing? Basically, the word heal itself means that whenever there is a damage, Kubernetes has to control the damage. Okay, so Kubernetes controls and fix the damage. So it will either control or it will fix. So most of the time it will control the damage. Now what is the meaning of controlling the damage, or what is the meaning of auto healing? So let's say for some reason one of your container is going down. There are hundreds of reasons why your container can go down. I'll explain you what are the classic problems of why a pod can go down or why a container can go down. There are multiple things, and there are some standard things that you can remember, or standard debugging steps for a container when container goes down. But for now, let's assume that your container is going down. So in case of Docker, like I told you, you have to look into the Docker PS commands, look into all the list of containers and understand, okay, one of my container went down, so let me restart or let me recreate this container. Whereas Kubernetes has a feature called auto healing. Using this auto healing feature, whenever the container is going down, even before the container goes down, Kubernetes will start a new container. Okay. So even before this container goes down, how Kubernetes will basically work is as soon as Kubernetes receives, in Kubernetes, there is something called as API server. Okay. So tomorrow I'll explain you the Kubernetes architecture. During that time, I'll explain you what is API server, what are the different components, or how the Kubernetes architecture is present. But for now, there is something called as API server. Whenever the API server understands that one of the container is going down, or whenever it receives a signal called container is going down, immediately what Kubernetes does is even before this container goes down, it will roll out a new container. Okay. So whenever it will roll out a new container, the end user will not even understand that the container has gone down and a new container has come up, unless your application, like let's say yours is a very heavy application, or in some cases that might happen. But I am only talking about the generic terminology or general usage purposes. So even before your container goes down, a new rollout or a new container is created or a new pod is created. In Kubernetes, we usually deal in terms of pods, not in containers. But for now, let's understand that even if your container is going down, before that, Kubernetes starts a new container. So using which we have achieved a feature called auto healing. So three problems solved. I explained you three problems: auto healing, auto scaling, single host nature of Docker. Because Kubernetes is a cluster, it has scope for putting one container from one specific node to another specific node. What is the fourth problem? The fourth problem is the enterprise nature. Like Docker, I told you, it does not has enterprise nature. Okay, so it does not have many enterprise support capabilities. Like it does not support firewalls, it does not support load balancers, or by default. Okay, so it does not support a lot of things unless you go to Docker Swarm. So what people have done is the people at Kubernetes. So Kubernetes is basically a tool that was originated from Google. Okay, so people at Google were using a specific tool called Borg, where they say that Kubernetes is one of the parts of Borg. So they say that Borg is a even a better solution, and Kubernetes is one of the, like, you can consider as one of the parts of blogs or one of Borg, or you can consider Kubernetes as initial solution for Borg. So we don't have much details here, but the people at Google, so Borg is not an open source tool. So the people at Google, what they have done is they have built an enterprise level container orchestration platform. Okay. So why they have built a container orchestration platform that supports enterprise level is because the Docker platform, which is just a container platform, right? Docker was just a container platform. So it does not have all of these capabilities. But to run your application on on a platform which is not enterprise ready, it is not suggestible, right? So that's why nobody used Docker in production. Okay, so Docker is never used in production. So you might use Docker Swarm in production, but Docker independently is never used in production because it's not an enterprise level solution. So Docker is basically a container platform which will allow you to play with containers on your personal laptop or on your EC2 instances. But in general, you can consider that Docker has some container runtime, which will allow you to run containers, or which will allow you to manage the life cycle of containers, but it's not an enterprise solution because it does not have all the list of capabilities like auto healing, auto scaling, load balancer support, firewall support, support for API gateways. Okay, so all of whitelisting, blacklisting. So These are all features that you require to run your application in production. Now, Flipkart or Amazon cannot just say that Docker platform is a platform that is running containers, so let me move to Docker. So the first question the organizations, MNCs, or your corporates will have is, okay, I appreciate a solution like Docker platform, but is it suitable for our organization? Does it support all of these capabilities? Because I want to blacklist few clients, or I want to whitelist few particular IPs. I want to blacklist somebody who is trying to perform DDoS attack or denial of service attack. So all of these capabilities are required, which Docker does not have. And Kubernetes is the one that is aiming to solve this problem. Now, does Kubernetes solve this problem 100%? So to answer this question in a nutshell, the answer is definitely no. So you might talk to experts in Kubernetes, you can talk to anyone like who have been in the world of Kubernetes. So it is not as simple as we do it in the world of virtual machines. Okay. So when we were dealing with virtual machines like 10 years back, or 7 to 8 years back, everybody was on virtual machines, and the way you can integrate these external tools to virtual machines was far easy. And virtual machines offer you far more security when you compare with containers. So Kubernetes is evolving, and it is backed up by very wonderful people at CNCF. Okay, so there are many contributors to CNCF. Even I am one of the contributors to CNCF, where the goal of this community is to make Kubernetes a better place. Okay, so you are basically, I mean, Kubernetes basically has a very good backup, and every day there are lots of enhancements that are done to Kubernetes. So you will see that there are many projects in the CNCF, like you have Podman, you have build packs, you have Prometheus. All of these are CNCF incubated, or CNCF adopted projects. So they might be created by someone else, but CNCF has adopted these projects. So what is the meaning is that there is a community that is constantly focusing on developing the Kubernetes community, not just the Kubernetes application, but the tools around Kubernetes. Because Kubernetes also by default does not provide you a lot of capabilities, but Kubernetes provides a concept concepts like custom resources, custom resource definitions, using which you can extend Kubernetes to any level. Okay, so let's say by default Kubernetes, for example, by default Kubernetes does not support advanced load balancing capabilities. Okay, so everybody knows this, and this is a practical truth. So by default Kubernetes has services and kube proxy, which will just give you some basic load balancing like round robin. But this is one of the major problems. And how Kubernetes solved this problem was Kubernetes introduced custom resources and custom resource definitions, and it told applications like F5, Nginx that, okay, you create a Kubernetes controller using which people can use your load balancer even in Kubernetes. Okay, and this concept was called as ingress controllers. So similarly, Kubernetes is advancing every day, and Kubernetes is improving, and it is reaching this near 100%. Okay, so we'll reach that near 100%. So that is one of the reasons why even some of the companies hesitate to implement Kubernetes in production. People are migrating slowly to Kubernetes in production because of all this support and all of these things. So Kubernetes is one such tool that you have to definitely watch out for. And like I told you in the very first slide, Kubernetes is easy. Don't worry about Kubernetes. If you understood these 4 topics that I told you, so today your part is done. Like, let's assume that you have learned already 5% of Kubernetes. Okay, now what we will focus is learning the next 95%, and this next 95% will completely depend on your foundations. That is your first 5%. That is to understand why you need to learn Kubernetes. If you understand the why statement, why you need to learn Kubernetes, then you will understand with your effort, not directly, with your effort in learning Kubernetes, you will understand the rest 95%. Okay, so we will slow by slow, I mean, in our next classes, step by step, we'll learn about the concepts like pods, we'll learn about the concepts like deployments, services. Even before all of these things, I'll explain you the architecture of Kubernetes. Okay, because that is very important. And on the very first day, like tomorrow, when I explain you the architecture of Kubernetes, might be some people might not understand the complete architecture, and you might feel that, oh, there are so many components in Kubernetes, now I have to learn about all of these components. But on the very first day, you will not understand all the components. I'm very sure about it. You might understand the definitions, you might feel like you understood it, but practically, to gain understanding of all the Kubernetes components, it will take some time. So don't lose hope. In our next videos, we'll start learning with pods, we'll start learning with deployment, services, ingress controllers, we'll start talking about admission controllers. So it is a long journey, and stay with me. You will learn Kubernetes definitely, because Kubernetes is very easy. I hope you like this video. If you like the video, click on the like button. If you have any feedback for me, definitely post that in the comment section, and don't forget to share it with your friends and your colleagues. Thank you so much for watching the video. Take care, everyone. Bye. See you in the next video.